Hello again, I'm Mark Miller from Livermore Labs. So I'm going to talk to you, I had hoped by this time of this year, when I originally submitted the proposal for this, that I would actually have more working than I actually do as far as this set of slides go. But so I'm more considering it a proposal for HDF5 scientific data compression community benchmarking. This is something I've spoken about with THD and the HDF5 team from time to time. So just an outline of what I'll talk about. Benchmark data sources, in other words, what scientific data sources might we use for benchmarking compression tools. An HDF5 command line tool that's very much like, gzip or szip or, unzip or pkzip or whatever, but what it does is it takes the original raw binary data files in and produces an HDF5 file out, and we time how long that takes and how much memory it takes up and so forth. So, and then writing some benchmarking scripts that then take and run this in various different ways on various data sets, gathering up tables and tables of data, very much like we would expect from compression benchmarking tools. In addition to that, again, making sure we document space performance. It's not just how long compression takes, how much memory it takes, how big the final file size is, including in that whatever HDF5 metadata and chunking issues may arise out of that. In addition, having documentation and examples of how to use HDF5 compression, so people who want to apply it to their data have a place to go. They can kind of see how it works and how to code it. And then finally, talk a little bit about maybe what we could do for a website for that and making yearly releases. So the goals, I can see in my slides, I changed the name of the site, h5zbenchmark.io. But basically, the goal is to keep community informed about compression capabilities in HDF5. So, what compression features are available, what their performance is, what's the best practices, and how to use them. Documentation and examples, and then just ensure that the performance of the library is maintained over releases of the library, releases of the plugins, and so forth. And if things pop up in the way of performance issues, we're aware of them rather quickly. So for benchmark data sources, idea number one, well, I guess sorry, I got maybe this is making it a little difficult for people to hear me. I apologize. So for benchmark data sources, idea number one, I just found this on GitHub, and I should have provided the URL, but there's a whole bunch of scientific data sets in this one GitHub resource. I'm just listing the top of the web page for them, but they're basically raw data files that have, a bunch of binary doubles or floats or whatever in them, and we understand the dimensionality and the data type and that sort of thing. Another idea is benchmarking data source is actually being able to synthesize data. This is actually some code that's in the Maxio IO benchmarking tool that I helped to develop several years ago, and it's using Perl and noise to demonstrate we can generate data, synthesize data at any scale that is kind of representative of the kind of data you might see like in a hydrodynamics code, for example. So when we're looking for benchmarking data, things to consider, obviously the size of the data sets, the data types involved, is it 64 or 32-bit float? Is it integer data as opposed to floating point data? What dimensionality it is, what its noise and smoothness properties are, I think is kind of important as far as the compression tools go. Maybe the file systems that are being tested on and parallelism, maybe thread parallelism down in the compression plugin itself. Not talking about multi-threaded HDF5 in that case, but just when you actually spawn the filter, whether or not it exploits threads. Okay, onto the HDF5 command line tool I have in mind for this. Again, it's basically just like gzip, except it's a H5 zip or whatever we'd call it, that is going to take on write case, it's going to read the raw binary file, and that's not going to be included in the time or space measurement. It's just to get that data into memory. So it reads the file in, and then it accepts various command line arguments, maybe the actual plugin name or idea, you can then specify the kind of data type information that's necessary, the type, the dimensionality of that data set, all sorts of command line options, maybe what your chunk caching is going to be, chunk sizing, that sort of thing. So very long command line to control how this tool is going to apply an HDF5 plugin to compress the data. And then it basically just sets up an H5D write call, times how long that takes, measures how much memory it takes up, and then reports the results on std out. Somewhat similar for reads, except in the case of reading, we're opening the HDF5 file and we just want to set up an H5D read and time how long that takes. So that's basically, I think we can put that all in one tool. Maybe we have a reader tool and a writer tool, I'm not sure. But let's see, then we want to compare this tool. So often what I hear is people say, well, I just took my data and gzipped it and it took this long. And now when I'm using an HDF5, it's taken forever and I don't know why. So often the standard by which the people in the community are going to ask how good is HDF5 in terms of compression is they look at these other tools, gzip, unzip, and they sort of time and then they ask how long things take for those tools to work. So we want to then compare this new H5zip tool to each of these to get an idea. Are we getting close to what they're getting? Obviously, we're not going to get exactly. It operates in different ways, but we should get relatively close. I don't know, 2%, 10%. I don't know what the right numbers are. In fact, does anybody on the HDF5 team want to suggest, or anybody that's highly familiar with HDF5, what they think it ought to be in terms of how close to these tools that I ought to come? Go ahead, Elena.
It should be very close because we did run this benchmarks with H5 using different chunking sizes, and it's also within 10%.
Within 10%,
right.
Okay.
So, but it depends, of course, on chunking size what you're choosing, and you can experiment with this. So
sure.
Chunking is very important.
Sure.
And when people say that they have better performance, usually it's not compression when they read and cache size, when they have read pattern where our chunk cache size is not right. So chunk always goes back and forth. Okay, so I'll summarize. What Elena has said is she would expect things to be within 10% of what these command line tools, I'll get you in a minute, Quincy. And say that again? Yes, absolutely, yes. In fact, I didn't have it on there, but I do have an early version of this implemented, and I do have the shuffle filter being implemented in the gzip case. But the summary is that chunking can obviously have a big, HDF5 chunking and the chunk cache can have a big effect on performance. So I don't know what we do regarding these other tools. Do we assume they're available on the benchmarking system, or do we have to build them from sources? To be honest, it might make some sense to build them from sources, because in order to be completely fair comparisons, you want to compile them to the exactly same standards that you compiled the H5zip tool to. And then you basically compare basically how H5zip would to each of these tools, and then include the file size in the comparisons. And then you have probably a bunch of Python scripts that are then able to run over all the data sources that you've identified and all the plugins that you want to test, and all the different scenarios. Maybe the scripts run for a few hours and gathers up a bunch of data on a machine that's not heavily loaded by other people, and then packages up the results in a JSON or YAML file for a pull request into the website that we'd have. So the documentation, the idea I think here is we document common use cases, the typical things that people would want to do. Again, this is documenting how to do this with HDF5, and maybe even document common pitfalls, because it's very easy to get yourself into trouble. And so you want to basically document those and say how you would mitigate those. And then also make sure that heavily link the HDF5 reference manual from whatever examples we create on this site, so people can get to the actual reference documentation on the different features in HDF5. So the idea is have a website with published results. That's very easy to do with something like GitHub Pages and Jekyll. So it might be like a C- thingy. I don't know. Maybe it would in fact be C-. I'm not sure. But basically tables of data and plots, maybe where they make sense. Curve plots, and then possibly important notices regarding HDF5 releases, and if any issues are discovered that people need to be aware of. And then maybe do this on a yearly basis, update the results and add new plugins as they become available to the list. Other things to consider, obviously, again, time and space performance. A lot of people, I think, look at time performance, and that's really important, but more and more we need to be looking at space performance of our software. Obviously, we want to test both compression and decompression. I don't know if we want to be too concerned about CPU architectures. I know I see that a lot in the standard compression benchmarking pages for things like gzip. They're talking about all these different swizzles on CPUs.
Not sure I care as much about that. Maybe people do. In this case, we're more interested in comparing the gzip tool on a given CPU to HDF5, for example, or XZ. I wanted to write an XZ compression plugin and got hopelessly lost in XZ, well, the lack of XZ documentation, to be quite honest. We probably want to test different versions of the HDF5 library, and as soon, it looks like beginning 2024, we're really going to have one version, essentially one release, but we're going to, at compile time, be able to select, are we using 1.6 or 1? We won't do NASA's 1.6, 1.8, 1.10, 1.12. We can control that with H5 P set libver bound, I think. CPU versus GPU, that may be a thing. I know, for example, the H5 ZZFP filter, I'll be talking about that later, actually is capable of compressing from GPU, and we're adding features to it to support that. Threaded compression and so forth. Just a handful of ideas we might want to consider. And that may be my last slide. Yeah, that's my last slide. So I can stop there. People ask questions. Greg, yes, go ahead.
So I think that information is good, but who is it for? The word compression filter developers to say I need to set a filter, for users to know, okay, this is how I chunk my data to get best performance, or otherwise it's just, okay, gzip does it this fast, gzip does it this fast, and I guess
so Greg's
deciding how I use this data.
Sure. That's a good question. So Greg's question is, what do we actually use this data for? So first and foremost, is to make sure that we are getting as good a compression out of the HDF5 library as we should expect. I have had too many discussions with users where they compare it to XZ or they compare it to gzip or pigz or whatever, and they're like saying, well, why isn't this going fast? And then the second thing, maybe you were asking, is it for developers or users? I think it could potentially be for both. We could have aspects of informing developers of plugins, but also aspects of informing users of these plugins that are trying to use it on their data. This question that you asked also about, what about chunking? Chunking plays a role, but it's very scenario specific. So you have to, that's a message that people need to understand, but then you could, maybe paint that picture with various of the data sets that are available. Does that answer your question?
Yeah, as a follow-on, it's like, this is probably all serial, or something with.
Well, so I had that up there on the slide as parallelism. I think, yeah, that's a thing. So we probably need to have some understanding of it and how it scales, and whether or not for example, collective IOs and HDF5 are scaling or rolling off a cliff. Yes, another question.
So I assuming by talking about performance, you mean the latency.
No,
about the compression ratio. How important is that?
So the ratio is not, well, I think is important. That's the space question, and it, yeah, that's important. It needs to be measured and it needs to be characterized. But no, my first question is, how fast is it going? Because it ought to improve, in many cases, ought to improve actual disk bandwidth for an HDF5 application. We have many experiences where it hasn't for some reasons. Often those reasons are inappropriate chunking, but not always. Yeah.
But if you consider multiple layers of storage, you potentially select a different, compression algorithm for different purpose. If for long term, like on tape, you probably select a different one than you store on SD.
So I'm gonna say that so the question is, maybe we select a different compression algorithm depending on what point in the memory hierarchy we're going to.
Yeah.
Archiving versus. So I'm gonna ask what are other. I'm not gonna respond necessarily to that. What do other people think of that notion?
Okay.
So the trade-off between time to store the data directly on the device, you have to trade off that with the time spent in compression. So you might have to say, I have to compress lot more, or I can probably compress a lot more on a faster device in the same time. Think of the time budget based on that trade-off. So talk about that. It does show some benefit.
Also, chunking as an algorithm, it may be the same, but different on different architectures. You know, all this can change. Yeah, yeah. Sorry.
Can we get our next speaker to start coming up with?
Question. So Mark, there are efforts like Charlie Sanders and Ed Hartner. I hope he's giving the talk today, right? Yeah. So are you aware of this? But there are. So
I will be when he speaks.
There are now several compression suites which provide compressions, different types of compression. And I think what is very valuable for user to be able easily to experiment. This is my data. I want to drop my data into your test suite and give me different, just random, so I can see and then choose which one to use, which parameters to use, because it may be different purposes. I'm, as a data provider, I want to create something that acceptable to me for write speed, but I also can use some tools with different access patterns to read data back and see that my users will not be harmed. What we found in the past that, for example, endpoints, they were compressing big chunks of data coming because it's how it was coming from satellite image, but it was impossible to read because of chunky cache. So this experiment of providing those tools to users will be incredibly useful, plus incorporating different compression suites that are available. And I believe Hug Meeting in Europe will try to address how many compression plugins do we have.
Okay, thank you for that remark, Elena. And I think my time is up.
I
So
am kicking you off.
I think,
Yeah.
okay.